This is another example problem of how to work with Hess's law in equilibrium processes. We're going to be going through a step-by-step example here, but if you need a review of the rules on how to do this, check out the video that I've linked in the corner of this one. Here's our overall process. Ammonia gas plus hydrogen chloride gas reversibly becoming ammonium chloride solid. We have three partial reactions, and we need to get them manipulated such that they reflect our overall process. Partial reaction 1, N2 gas plus 3H2 gas reversibly becomes 2NH3 gas with a K of 8.43 times 10 to the minus 32. Partial process 2 has H2 gas plus Cl2 gas reversibly becoming 2HCl gas with a K of 2.25 times 10 to the 18th. And our third process has N2 gas plus 4H2 gas plus Cl2 gas reversibly becoming 2NH2Cl solid, which has a K of 6.91 times 10 to the third. If you'd like to take a stab at this yourself, go ahead and pause the video now and then start it up again once you've got your work done. First, I'm going to describe how we're going to manipulate these processes to get them to add up the way we want. We're going to need to flip process 1 and multiply it by a half. What that does is it's going to get our ammonia from the product side to the reactant side and give it the right coefficient. That also means that we're going to have a 1 over K1 square root of that whole thing as the manipulated equilibrium value. Partial process 2 is getting the same treatment. We're going to flip it and multiply it by a half to get HCl over in the reactant side where it belongs. This means that the new K will also be square root of 1 over K2. And finally, our last process, we don't need to flip this one. We've got the product right where we want it, but we do need to multiply it by a half. Therefore, we'll be taking just the square root of K3. First, we're going to verify that the manipulations we've done are going to give us the overall equation that we need. So we've got our manipulations that we predicted. I'm going to apply those to each of these partial processes. So we've flipped process 1, multiplied it by a half. Now we have NH3 becomes 1/2 N2 plus 3/2 H2. Process 2 has been flipped and multiplied by a half. It is now HCl becomes 1/2 H2 plus 1/2 Cl2. And we have just multiplied by 1/2 process 3. 1/2 N2 plus 2H2 plus 1/2 Cl2 becomes NH4Cl. If we look at these, we've got a 1/2 N2 on both sides of the arrows, so that cancels. Same thing with the chlorine. And if we take the total 1/2 H2 plus 3/2 H2, that adds up to 2H2, which cancels out all the hydrogen. All we have left are the process components that we wanted as our target. So now we know that these manipulations are good and we can move on to our math. Remember that the K overall is going to be the product of the manipulated Ks. In this case, we're going to have the square root of 1 over K1 times the square root of 1 over K2 times the square root of K3. We can plug in our numbers. That's going to be the square root of 1 over 8.43 times 10 to the minus 32 times the square root of 1 over 2.25 times 10 to the 18th times the square root of 6.91 times 10 to the third. Now if we do our crunching, after we crunch them all down and the dust settles, we get a final answer of 1.91 times 10 to the 8th. This is a K much, much greater than 1, which means that the forward process is spontaneous. If we mix NH3 and HCl, they're going to make an awful lot of NH4Cl. You can see this reaction in the video I've linked in the corner where scientist sets up the vapors of these ammonia and the HCl meeting inside a tube so you can see that NH4Cl forming as a white solid. So there you go. There's another example video for you, and I will see you guys in class.